This is the efficiency of electric vehicles, a data development analysis for Management 426. The goal of this project is to determine the efficiency of 8 randomly selected electric vehicles by conducting a DEA analysis using battery capacity, miles per charge, and top speed by the vehicle price and the acceleration. The market analysis shows that EVs are on the rise with a 26% market share in some states like California. In 2024, the average electric vehicle price is $56,000. This is due to a drop in price and increased social environmental awareness. The vehicles that I chose for this project were the Tesla Model S, the Chevy Bolt EV, the Volkswagen ID.4, the Honda Ioniq 5, the Ford F-150 Lightning, the BMW i7, the Ford Mustang Mach-E, as well as the Rivian RS1. These are the formulas that I used for this project. As you can see, productivity is weighted output over weighted input. The formula below that is what I used to solve for each DMU on Excel. And the one below that is a constraint formula that I use on Excel as well. The efficient vehicles in this project were the Tesla Model S, the Chevy Bolt EV, the Ford F-150 Lightning, and the Ford Mustang Mach-E. All these vehicles scored an objective cell final value of 1 on the answer report. The vehicles that were inefficient were the Volkswagen ID.4, the Honda Ioniq 5, the BMW i7, the Rivian R1S. The Volkswagen and the Honda both scored 87% efficient. The Rivian R1S was close to being efficient, but only scored 99%. And the BMW i7 was the least efficient vehicle in this project at 68% efficient. You can see that in my inputs and outputs. These are all the original actuals of what each vehicle does for battery capacity, miles and charge, top speed, etc. For example, the BMW i7, which is the least efficient vehicle, has a mile per charge of 318, meaning that it can go 318 miles on a single charge, and a top speed of 149 miles per hour. If you go to the improvement table, which is after all the calculations, this shows what each vehicle would need to be efficient. The miles per charge would have to be 380 and 187 for the top speed. So an increased miles on a single charge, as well as an increased top speed for it to be efficient, as well as a lower price, as it was originally priced at $105,000. So how can we increase the efficiency of these electric vehicles? One would be increasing the battery efficiency, which would allow for more power, more miles on a single charge. Adding charging station availability would increase the practicality of these vehicles, allowing more people to want to use them, increasing the demand, which would then potentially fund more research that could increase battery efficiency as well as reducing the manufacturing cost. Reducing the manufacturing cost would be important because you're going to have a cheaper product and allow for the masses to be able to afford electric vehicles. Increased social responsibility is also important in increasing the efficiency because more people are going to want to purchase these vehicles when they realize how harmful coal and other fossil fuels that produce gasoline that current cars run on does for the environment. So thank you for listening to my presentation.